You see my screen? So in our folder, so this folder we will be having all the recording sessions related to our sessions. And next, this is the folder, machine learning code folder, where we will be accessing code related to clustering, classification, and regression. So first we are going to check the project related to regression. So let us see how we will be building the regression project, and let us see how the problem statement came into picture. What is the problem statement? What we are trying to achieve here? All those things we will be looking now. Okay. So now this is the problem statement given by the client. So this is one of the project where we did for one of our clients. So here you need to read the problem statement first of all. So some scenarios you will get the problem statement clearly like this, and in some scenarios you will get the problem statement orally. So the manager will be explaining, and you need to make a note of that problem statement, and you should understand that. So here, just read it. So anyway, this doc file also available in the drive, where it is. The linear regression, you will get this file. Yeah. So problem statement sales. So this is the document which you will be getting, whatever the thing I'm sharing right now. So that is the problem statement file. So what is the problem statement? Our client. So here our client is manufacturer A. So there will be multiple manufacturers in the data, but we are focusing on our manufacturer A is a leading food and beverage manufacturer. Client wants to understand the growth patterns of consumer preferences and evaluate positioning of their brand across different things. Client also wants to know the sales drivers of their products. So below, the client provided the data sets for us. So first data is sales data. So client will provide the following data for the project. So sales data at UPC level for both client and competitors. That is, our manufacturer A data is available and other manufacturers data also available. So here the client data is confidential. That's why the client name is not exposed here. So we are just maintaining the client name as A, B, C, D, like that. And next data source is social media data. Mentions of themes across all social media platforms. Normally, the companies will be doing campaignings in social media platforms like Facebook, Twitter, all those things. They will be providing ads. So that data also provided by the client. And next, Google search data. So here the client provided so Google search related data, Walmart related data, and some other sources, Amazon search related data. All those information also provided to us. And next, theme products list. So this theme products list is nothing but under which theme the product is there. For example, if all the milk related products will come under one theme, all the dry fruits related products will come under another theme. So all bread related products will come under another theme, like butter, jam, like this multiple themes. So product manufacturers. So some products are manufactured by our client and some products manufactured by other clients. So this theme list is having unique ID and its name. So these are all the data sets. Let us see how many data sets we have. 1, 2, 3, 4, 5, 6. Total 6 data sets are available for us. Normally in the real time, you will be getting all these 6 data sources will be saved in any one of the database or 2 databases, something else like that. So either you will be getting data from the SQL Server or Oracle database, Mongo database, or something else. Multiple databases are there. So next, what we need to deliver. So what are the tasks we need to deliver? So what is the first task we need to do? Data preparation from available sources. So in the data preparation, what we need to do? So first question is merge the required data sources. So why? Because we do have multiple data sources. In our pandas, we learn about the merging. So how to do the merging, all those things. The first step is that one. We need to merge the required data sources. So next thing is provide the list of themes available across all data sources. And next, understand consumer preference themes available in each data sources. That is, which themes is having higher sales, like that we need to provide. And next, provide a report for data sufficiency, sparsity, and anomalies in each data source. So, is there any data loss? Is there some? Is there any more null values are there in your data set? All those things we need to check. That is what it is mentioning. So next, exploratory data analysis. Exploratory data analysis is simply you need to understand the theme-wise sales, so manufacturer-wise sales. You need to do the plotting. You need to explain to the client and find the potential competitors for our client in each theme. So each theme, so how many manufacturers are there? Either you need to do analytics from your Excel point of view, or you can do analytics from the Python EDA point of view. So next thing is there any trend seasonality across themes? You can ignore this. And next, identify top 5 themes with the highest business opportunity. Back up your top 5 with valid reasoning. So top 5 themes means which theme is having higher business for our client. And at the same time, competitive also. For example, if our client is maintaining a sales of $1,000 for one theme, how much competitors are doing for the same theme? Like that, you need to check. So next, what we need to do? Build the sales model and identify the driver of sales. So perform appropriate data transformation aggregation to build model, create a dependency variable by aggregating sales of our client to corresponding theme level, estimate the impact on sales due to social trends, set trends, own price. So here just like we need to build the model. So that means after merging all of our data sets, we will be getting one final data set. With that final data set, we need to divide input data, target data, and we need to build the machine learning algorithm and we need to predict the sales. So the sales value. So we need to predict the sales value for our model, for our client. So the next thing is identify the drivers of sales. So here drivers of sales means in our linear regression algorithm, we have seen coefficients of each and every feature. For example, if you have 10 features, you will get 10 coefficients. So if the coefficient value is high, that means that feature is important. If the coefficient value is nearby 0, that means that feature is not important. So that feature will be called as driver. That means it is having more impact on the sales. That is what we need to that is what we need to do now. So that is what we are going to type with this problem statement. Before going to this problem statement, we need to see each and every data set and we need to open in Excel. So normally in companies, if you have any tool like Power BI, Tableau, or Kibana, or any other tool like ClickView, you can do analytics from that tool. If you don't have that availability of that tool, you can open those data with the Excel files. It's Excel also for our data analytics purpose only. So now let us move on to the data set. So what is the first data set mentioned in the problem statement? This is how you need to do in your real time also. That's why I'm explaining clearly one by one. So first you need to open the sales data. As of now, clear everyone? See guys, if you ask me questions, then only I can understand whether you are able to understand, whether you are able to follow or not. Actually, this dataset size is huge. Normally, Excel file can handle till 10 lakhs rows of data only, around 10 lakhs 8,000. So here our dataset is more than 10 lakhs. So it can't handle. See here, count is 10 lakhs 48,576. If you having dataset with more than 10 lakh 48,000, Excel can't open. Excel can open till 10 lakhs 48,576 only. So now let us see, we need to just check each and every feature. So system calendar key in. So next product ID. Product ID means that product ID. So respective ID. So sales dollars value. So that means how much revenue generated in dollars. For this product one, this much revenue generated. Let us see the same product ID by filtering across multiple days. If you see this date, this is the date. If you read it, you can understand 2016 0109. That means 2016 January 9th. Normally, this is date, this is month, this is year. So let us check with product ID 1 how the sales value got improved. So around 48 rows of data related to product 1. See, first, this product sold at 9th January. Next, this product sold at 23rd January 2016. So some days are there. So first day, the sales value is 30,920. Again, it's reduced. Again, reduced. Again, same. Reduced. Same. Little bit increased. Little bit increased. Like this. You can draw the graph also for this. Next, sales units. Sales units means how many products sold. This is total dollars value. This is units value. And next is sales LBS value. That is the weight of these products. Okay. So this is the first data set. At least we are able to analyze. So let us go on to another data set. From the problem statement, next data set is social media data. So let's move to social media data and open it. This is the social media data. So whatever the data I'm showcasing, so this is extracted from the database itself. Just for our to make our life easy, we saved in CSV and Excel file. So this theme ID. So this theme ID means we have discussed, right? Like milk related products, dry fruits related products, all those things. The description is different and this ID is different. Like milk related product, one ID. Bread related products, one ID. Like that. And the date, published date, at which date it got published. And the total posts. So 76 posts got posted, published for this specific theme ID. So you do have multiple theme IDs here. You need to just filter. Yeah. These are all the multiple theme IDs. Like product name, product ID will be there, right? In the same way, theme ID and theme name will be there. So now let's move on to another data set. Next is Google search data. So let's move on to the next part. What is the Google search data? This is the Google search data. On which date, on how much value it got searched, and what is the claim ID, and what is the week number, and what is the year. So it's provided. Let us check how many platforms it got published, it got posted. So how many percent searched in how many websites? See, Amazon, Chewy, Google, Walmart. Normally, this client is US based client. So normally we will be having Amazon, Chewy also one of the thing. Walmart they will be searching. Walmart is one of the biggest retail market in US. So four things. Apart from Google, there are multiple platforms out there. So next data source. Let's go to the problem statement. Theme products list. What is theme products list? So this theme product list, either you can take CSV file or Excel file, anything is fine. Both files are same only. See, this product ID and this claim ID. Normally, this claim ID and theme ID both are same. That how we will understand is we need to, after analyzing, we will understand that claim ID and theme ID both are same. So we will be discussing with our manager, with client. We will get to know that theme ID and claim ID both are same. Some person saved the team ID with claim ID, and some person saved with claim ID. It's like name differentiation only, but the data is same. See, in this team products list, claim ID is available. But in another file, another Excel, another CSV file, is with here also it is claim ID. But the claim ID name is not same. Just observe. It is case sensitive. Python is case sensitive. The name should be same across the board. Here it is capital, small letters, and capital letters. In this is Google search data. And theme products list, it is in the product, it is in the capital letters completely. These are all the data issues we need to fix as a data scientist. So next, product to manufacturer list. So let us open product to manufacturer list. This is the product to manufacturer list. See, we should be having a lot of patience in the data analytics. Writing a code, building a machine learning model, everything is easy. But data analytics is very tough as compared to anything. Why? Because to survive, to do the machine learning model, you need to do the data analytics. That is mandatory. Next, vendors. Vendor is nothing but manufacturer. Let us see where is our manufacturer is there. See here. These are all the manufacturers. A, B, D, E, F, G, H, others, and private. Something else. They didn't provide manufacturer names. It's confidential. See, all these 5,584 rows of data related to our vendor only. Now, let's move on to the another data source. Theme list. That is theme names. Let us open the theme names. Yes, this is the theme list. See, theme list is different file and theme product list is different now. Theme list, you will be having description for each and every claim ID. See, this is the claim ID we have already seen in our previous data sets. Now, see the names here. Claim ID 8 means low carb. Claim ID 0 means no claim. That means it is miscellaneous. And 15 means it's beans related products. Like this, search. See, this claim ID 100 related to low calorie and milk related products, somewhere it could be. So low sodium, low sugar. This is the description and this is the respective ID. The client is maintaining for their easy purpose. Like this, pizza related IDs. So till now, we are able to understand about multiple data sources. Now, let's read what is the next task, what we need to do. Merge the required data sources. So let us move on to the code and let us see one by one. So how the data extraction, data reading, all those things will come into picture. So now linear regression, which we built. So when it comes to any regression problem statement, first we will try with linear regression, then we will go ahead with some other algorithms. But this is the benchmark. This is the basic model. First we need to understand and we need to try. Everywhere. Yes. So what I'm doing, this import warnings is maybe if you are getting some version differences, we will be getting these warnings. To overcome that, we will be using this at the starting of the code. If we use this, that warnings and those errors won't come. Not errors, that warnings only, version related warnings. What I'm using, I'm just importing and I'm just providing the path. Whenever, if you want to provide path like this, you can provide at the starting, or if you want to provide the path at the reading of the file, you can provide like that also. So what I'm doing, this path I'm changing. So you need to do in your local lab, local machine, not in this Google Cloud. If you are doing in Google Cloud, there is no need of these lines of code. You can ignore that. Okay, so I'm just importing Seaborn also to do the analytics. In between, wherever needed, I will import the libraries required for me. So first what I'm doing, I'm reading the sales data set. I'm just reading and I'm just checking header, and I'm just checking tail. See, entire data is available. Next step, info. Next step, shape. See, the data is 45 lakhs around. 45 lakhs, 26,182 rows. So next, I'm just checking the null values. So there is no null values in this sales data. That is good. Next, I'm checking the info and description. So each and every feature, it is mentioning. See, system calendar key also we are getting in the describe. That means this calendar key is saved in the integer format. That is not time. Normally, that is date time. So we need to convert that into date time. See, with the info, you are able to find out. System calendar key n is in integer 62. We need to convert this into date time format. That is the next step we need to do as part of our data pre-processing. For that, what I am doing, I am just importing data date time from the date time library. What I am doing, I am converting this system calendar key into the date time format. So here we have already discussed. Here my date time is in the format of year, month, and day. So that's why I am writing this line of code. If my data is in the format of month, D, and year, I can write percentile M, percentile D, and percentile 1. If you see the data set here, it is in this format. We need to identify that format also. This is in this format. That's why you are writing in this format. Then it will understand. The pandas will understand. So, for example, what if you have 27 01 2018? Then in that scenario, you need to write in the code format equal to. So what we got it first? So percentage D, percentile D, percentile M, so percentile Y. This is how you need to provide the format. Then it will understand. So if you have month at the first, you can just mention percentile M, percentile D, percentile Y. Like that, you need to do. So these are all the things will come as part of the real-time things only. These are all the things that won't come in dummy projects, all those things. So all these issues we will face in the real time. See, now my data set got converted into date time 64 nanoseconds. This is in the format of pandas date time format. So next data set I am reading. First data set I read it. I was able to check the null values. I was able to convert my data types. So whatever needed for me. Except this date time, everything is numerical only. Numerical and float. That is integer or float. Let us check. Everything in the format of integer or float only. That is fine. If it is any null values, we need to fill those null values. But we don't have any null values, surprisingly. That is fine for us. Next, reading the second data source and saving it to another variable called Google sets data. Next, same scenario, checking the header, checking the tail, checking the info, just checking value counts. So how many rows of data related to Google, how many rows of data related to Amazon, how many rows of data related to Chewy, how many rows of data related to Walmart. All these are our previous code only. Whatever we have discussed in our Panda session, everything from that Python code only. Nothing new I have written here. So I'm applying the same value counts for multiple features. Like year new. So how many rows of data related to 2018? It's just like checking how many years of data available. If you see here, 14 data available, 15, 16, 17, 18, till 19, we do have data available. Why? Because this is old use case and old data set. We got data till 2019 only. So next, as usual, checking the shape. See, here also, the date column is saved in the object format. In first example, date column is saved in integer format. Now it is saved in the object format. Now what I need to do? I need to convert this object into the date time 64. For that, this is the line of code I have written here. So in above thing, in above date time, without hyphens, without spaces, it's completely combined. That's why we have written percentile M, percentile D, percentile Y like that, like this. Okay, but what if my data set like this? If my data set is divided with hyphens, then I need to provide in the same format. So 27, 01, 2018. So in the percentile D, I need to provide hyphen, percentile N, I need to provide hyphen. Then it will easily understand, it will convert this into the pandas data format. That is what we did in the next data source. Google search data, yes. Now see the format, percentile D, percentile N, percentile Y. I did it. So next, checking null values. Surprisingly, here also there are no null values. Let's move on to the another data set. So till two data sources, we are able to do basic cleanup. Next again, I'm just checking again whether my date time is converted into date time or not. So next, so here what I'm doing, I'm just sorting by date. I'm just sorting by date. Why? Because I just want to take the first 2014 data of the first, remaining years of data next. 1 minute, guys. Okay. So now what we need to do? We just need to take same scenario, next data source also, theme products list, checking shape and header, same scenario, applying for social media data. So there also checking. See, majority of the rows of data is not having information related to theme ID. If you are not having information related to theme ID, that means the data is not important for us. So simply we can drop the data related to theme ID here. That is what we are doing here. Why? Because what is the use of having the data without having theme ID name? So that's why I'm dropping it. So next, I'm just doing reset index. Theme ID. Theme ID, if you see, it is in the format of float 64. Normally, this IDs we will be saving the numerical format. So that's why we are just doing. Okay. The theme ID normally it will be in the numerical format only. There won't be like 0.5, 0.7. So we will be getting in the integer only, right? So that's why converting into the integer 64. That is what we are doing. This is just like a basic common sense only. Nothing more than that. So these are all the things we need to focus. If you are getting one thing here, we will be applying the same here also. So next, again, reading another data set, product manufacturer list. So this is related to product ID and the product manufacturer name. So which product got manufactured by which person, like that we are checking all those things. So these are some unnecessary columns. That's why we can drop this. Maybe in your dataset, whether you get it or not, I don't know exactly. So if you are facing these unnecessary columns, you can drop them. See, it is like dropping the columns. So this thing also we have already discussed. Everything, whatever we are seeing. So this is one line of code by using the dropping methodology. This is same without dropping the column names. It's like selecting the column names whichever needed for me. Out of all the columns, I'm just selecting product ID and vendor only. So next. Again reading the another source file, claim ID and claim name. So just here also checking the null values, checking. So how many? I'm just checking the unique values for claim ID. So how many unique values are there in my claim ID? So if you see 208 unique claim IDs are there. That is 208 types of products. It's not about products. It's main theme. So 208 is the main themes like milk, miscellaneous, and carb, low calorie, high calorie, bread, butter. So in the milk, again you will get more products. Like milk is one of the product, curd is another product, ghee is another product, like that. So for example, in the dry fruits is one of the claim ID. So in the dry fruits, you may be getting the products of kaju and some other products uh, like badam, all those things, etc. Like this, 208 themes we do have. Within these themes, we do have multiple products. To check the how many products you do have, you just need to check the product ID n unique in our sales data set. You will understand. So next, claim name. So these are all the names. IDs, we check the unique values, and names also we check the unique values. See, all of them. Red apple and coffee, weight management, so vegetables. So vegetable means all the vegetables will come under this thing. And they divided some red tomato. This is another. And blackberries, whatever the berries will come under this. And papaya related things will come under this. And passion fruit, something else. They will be maintaining all those things. And next, so as of now, basic data analytics we did. I'm just checking each and every data source at a time. And we have already discussed. So in one data set, in social media data, we do have name as theme ID. And in another data set, we do have this theme ID name as claim ID. We need to identify. So how I will understand from this theme ID, claim ID by doing analytics only. You need to spend time on the data set. If you don't understand anything related to those features, we can simply ask our manager or client. There is no bad in asking. We can clear our doubts. So what I'm doing, I'm renaming this theme ID column into claim ID. So this claim ID also capital claim ID I'm converting. So these are all the data pre-processing. That is data cleaning. So next, claim ID is fine. Here also product ID is fine. And here also claim ID, capital letters is fine. So here also product ID, claim ID. And if you see in one example, product ID. Yeah. In sales data, product ID in the smaller case. But here it is in the capital case. Python is case sensitive. We need to equal the column names. That's why I am doing the rename of small product ID into product capital product ID. It's up to you. If you want to convert capitals into small, you can convert. It's up to your decision. No one will ask. Why did you convert smaller to higher like that? At that time, you got that thing. That's why you converted like that. So same thing in our Google search data, we do have claim ID in the small letters. See, these are all the data issues we need to identify. To identify this, we should have patience. So claim ID, if you see it, you can't understand. Here also it is claim ID, here also it is claim ID. So everything will come through practice. Everything, if you start doing digging about the data, you should start reading about the data. All those things you should understand. So next, renaming of feature names, renaming of column names, all those things we have converted. Again, we are checking all the data sources. And next, my next thing is, once the data cleanup is completed, I need to start merging the data sources. So I need to identify one common column from one data source to another data source. That is one data frame to another data frame. We need to identify one common column. So first what I'm doing, I am just doing merging from sales data and product manufacture data. Why? Because already this product ID is available in this data set and this product ID also available in this data set. I want to add this vendors column to my sales data set. That is, here it will come. This vendor, whatever vendor, he will come as another extra column at this place. So 1, 2, 3, 4, 5. I want to get 6th column as vendors. For that, I am doing this merging. So this sales data is my main data source. This is my key data source. Whatever the extra features, I'm planning to add everything to the sales data only, like here one column, here one column, here one column, here one column, like that. So that's why I'm doing left join only. I want sales data as it is. So simply merging code, left data frame, right data frame, house equal to left, and R equal to product date. Whatever the column name we need to merge, we are just merging. So whenever I'm merging, I'm creating a variable name which will be understand. So if I read this feature name, I can understand. That is sales product manufacturer. That is by combining these two variable names, I created one small feature name, which is easy to understand. So next, see the data. Before you do have data related to sales LBS value only, till here only. Now this vendor column got added here. After checking, see, before it is 5 columns, now it is 6 columns. Again, I'm checking the null values. After merging, we need to check first of all this null values. You can put here. So we will be again, what we need to do, sales product manufacturer head, see here. Now this vendor column got added. So now product ID is there. Now I want to add this claim ID. After this thing, same scenario following next thing also. Same merging with another data frame. After merging, again I am checking the data, again I am checking the null values, and again I am checking. Like this, we will be doing merging from one data frame to another data frame. So this is merging and concatenation example. So here we don't need of concatenation, we just need merging now. Okay. So now let's move on to another thing. Same applying with another data frame also. Like this, till all the data frames are merged into one data frame, we will be making the merging happening from one data source to another data source. This is my final data source. So date, ID, LBS, vendor, claim ID, claim name. See, everything came into picture. Date, product ID, sales dollars value, sales units value, sales LBS value. What is the vendor name? That is manufacturer name. Vendor is nothing but our client. So in this, our client is A, and the claim ID and the claim name. All those things we got it. So what I'm doing, I'm taking all the manufacturer's data So here, if you want to select only our client data, you can select only our client data also. And here also, I am selecting top 3 themes. So with my analytics, I was able to find out that no climb, low carb, and no additive preservatives is the top 3 claims. How did I identify that? By using this value counts. By using this value counts, whichever came top of the 3, I am taking that data set only. So if I take entire data set, it will take a lot of time for my training, all those things. So that's why I have considered these 3 only. So if you want to consider what you can do, if you want to consider only manufacturer A only, you can select like this. You can replicate the same line of code and you can select manufacturer A. So next, what I'm doing, I'm just taking the data set whichever needed for me. So here I didn't do any analytics. I just left analytics for you guys. You guys should do the plotting, product wise plotting, sales plotting, all those things. Why? Because we have already discussed some plotting in our cluster and causing. Just try to replicate the same things in this project also. You guys should try from your end. So I just selected the feature names which are needed for me. Claim name is not needed for me. Why? Because claim ID and claim name both are reflecting the same only. What is the claim name? I just used just for my analytics purpose only. This claim ID I will be taking for my model, and I just started building my model. So if you see, all of my data set is in all of them are in the integer format only. So there is no need of converting numerical data again. So we just need to use the data, and we just need to split our data set into training data, testing data, and we just need to maintain what is input columns and what is output columns. So till here, all of my input columns, and here it is my output column. So next, I'm just doing the pair plot on the base data set, nothing more than that. And next, what I am doing, I am just checking. So this label encoder is not needed for me. Sorry, vendor is there, right? Yeah, vendor. Sorry, this vendor is object. So this is in the categorical column. I need to convert this categorical column into numerical data. So that's why we have used this label encoder here. So once if I use this label encoder, my vendor is converted into the numerical data. Let us say vendor is 7 now. That is, it is able to convert it into numerical data. It is able to convert from 0 to 8. Why? Because 8 manufacturers are there. So once it is converted, I saved in another variable base data label encoder. And next, I am dividing my X data and Y data. So from X data, what I'm doing, I'm simply dropping the sales dollars value. Sales dollars value is nothing but sales volume. And in the Y, I'm taking sales dollars value. So X and Y, simply X we are taking, Y we are taking, and next I'm splitting my data set into X and Y and taking 20% of data as test, simply checking the shape again and importing linear regression, importing linear regression model, just using fitting of training on the test, and next predicting on the test data, whatever the test data I do have, and we are calculating the error also. This is mean absolute error. So either you can do it like this, or you can use the metric name like mean absolute error, mean square error. So first I tried with linear regression. Next I tried with lasso regression. So lasso is nothing but regularized format of linear regression. Next I tried with ridge regression. So next what I'm doing, I'm trying to validate my model. So for my validation, what I'm importing, mean absolute error I have imported, mean square error I have imported, and R square I have imported. So what I'm doing, I don't want to run each and every algorithm again and again and again. So that's why I created a for loop. So in this for loop, I have taken a list of algorithms like linear regression, lasso, and ridge. So it will take first parameter linear regression, and it will fit on X train and Y train, and it will predict on X test, and it will calculate MAE, MSE, RMSE, MAPE, R square. These are all the performance metrics we have already discussed. All of them I'm calculating from the Python and from one function itself. So whatever the values I'm getting here, right, MAE, MSc, RMSc, I'm adding to the validation table list, empty list, whichever I have created here. So I'm appending. Append means all those things. This I means algorithm name. This MAE, accuracy related to that algorithm, MSc related to that algorithm. Like that, these three algorithms, accuracy will come. It will take time for you guys to execute this code. Why? Because the data set is huge. Normally in the real time, sometimes we will be running the code in the server. Sometimes it will take 2 to 3 days, and sometimes it will take 1 week also to train the model. We should be patient. Within that time, we need to look into some other things. See now here, linear regression. This is a mean absolute error. This is the error value. This is MSc value. This is RMSc. MAP, we are not getting anything. So this is infinite, some issue happened. And next, R square. So by reading this R square value, 0.75 means 75% of the data we are able to predict correctly. That means 25% of the data we are able to predict wrongly. Wrongly means not that much correctly. So 75% of the data lying nearby the regression line. So next, what I am trying, I'm just trying with another algorithms like decision tree regressor, random forest regressor, bagging regressor. Just checking. I just modify above function into the above code into the function format. Why? Because in the real time we need to convert into the functions format on that. So train and test. So whenever the training happen, this code should run. Normally, this is how you need to write in the real time. So when training is happening, this if loop code will run. When the testing is happening, this code will run. So what see here, if my training is happening, this is my accuracy. All those, this is the accuracy on training data. See, linear regression is having only 76% accuracy, but random forest is giving 100%. The error rate also decreased rapidly. Here error rate is around 14,000, but here it is only 14. That is the benefit of linear regression as compared to, so linear regression is having very less capability. So decision tree regressor and random forest, we will be having a lot of capability completing these things. See, here also it is working fine. Decision tree regressor, random forest regressor, bagging regressor. So normally in our terminology, we do have two terminologies called overfitting and underfitting. So if you see the count here, if I test on test data, here the accuracy is same I am getting. But in the real time, if you are checking on the some data sets and some projects, the training accuracy is around 90% and the test accuracy is around 60%. There is a lot of difference. That scenarios will be called as overfitting. Let us suppose training accuracy is high, just assumption value 95%. So test accuracy is low means, for example, 55%, 30% like that, 55%, 60% like that. There is a lot of difference from training accuracy to and test accuracy. And underfitting is, if the training accuracy is low, that means 55 like that you will get. And the test accuracy also low. That means you will get very low as compared to the 40%. So these are the two terminologies we need to remember. If the training accuracy and the test accuracy is not same, that means it should be nearby plus or minus 5. That is fine. But it should not have this much difference, 95%, 55% like this. If your model is not working on the test data, that means it is not performing well. That is what we are doing. So next what I'm doing, I'm just checking the coefficients here. So each and every feature coefficient value. So product ID minus 0.03. So sales units value 0.5 LB. So from here we can say these two are very important, vendor and claim ID. So these are maintaining good support in predicting. So in the real time, you may in some projects you may be getting 15 to 30 features and 50 features, 100 features like that. So out of those 100 features, you can select the top features which are important to us. So just like printing the coefficient values, apart from multiple things. So till now, clear everyone. So this next what I'm doing, I'm just trying to apply the standardization concept, and again I will check the accuracy. So if you want to go with the other linear regression project, so in this GitHub, I just saved another project. You can go through this another regression project. You can go through the code here also. So this is another regression project. And one more thing, for your practice, I will be giving another project to you guys. You should complete that project also before going to the classification project. Yeah. So this is the project and code and the data set. So this is another GitHub project related to regression. This is another prediction. It's not sales prediction. It is refinance prediction related to banking domain. So I will be sending another problem statement and another data set to you guys for the assignment. We should complete that project and you should submit to me. So clear as of now. So I am leaving tomorrow for your practice and completion of this project. So everyone should execute the code and come up with your questions on Thursday. Why? Because you should execute the code, you should understand the code, you should come up with your questions. If you are not asking question means I will move on to another project. I don't want to waste my time and your time also. So just tomorrow is left for you guys. Today and tomorrow, practice on the code and see another project. And for this weekend, I will be giving another assignment on regression. So if you don't ask questions on Thursday, I will move on to the classification project. So if you have any doubts till now, you can ask me. So already the code is available, the data is available, the problem statement, everything is available. You just need to explore to each and every point. So once regression is completed, so once this classification is completed, I will show how this model will, this ML models will be saved and how we will be using in the real time. I will show you the deployment part. Maybe next week I can show it to you. Okay then, if you have any questions, you can shoot out or else we will adjourn for today. Please practice the code. That is my humble request.